Login accepted.
Welcome to the Automation Challenge Kubernetes Operators versus Helm charts. A little bit about myself. I'm Anna. I'm a Java Champion Certified Architect, and I work as a developer advocate for Red Hat, meaning I am sometimes contributing to open source projects or creating tutorials or workshops on best practices and how to work with different technologies that Red Hat also contributes to. You can find me on Twitter at Ambra1508 with double M. Where I can post on different sessions that I'm holding or whatever tutorials and great stuff myself and my colleagues are doing. This talk is going to address the other part of the native Java, the Kubernetes native Java world, like Kubernetes related and automation and how automation happens with Kubernetes. So, in order to choose how to automate better what we're doing with our deployments in Kubernetes, we have to kind of know what can make us go forward in dealing with Kubernetes, and of course, what's not so great about working with Kubernetes, and of course, choose the path that is leading us to success. So those being said, I think that for quite some time you've heard the concepts of microservices, and many of you are seeing that microservices kind of get associated with Kubernetes from infrastructure perspective. If you want to make microservices, nowadays, de facto, Kubernetes is the infrastructure supporter for doing that type of architecture. The reason being is because, well, with the divided empire architecture, with containerization and all the goodness that comes with it, you need something that can help you to orchestrate that part. However, many people choose Kubernetes because it has certain features. And these features, by the way, you can find them on the kubernetes.io first page. And it promises self-healing, which sounds great, like there's an infrastructure that heals itself. It has horizontal scaling by default, can offer you automated rollouts and rollbacks. Another great thing that probably in the past we didn't have with other types of infrastructures. We had like make scripts and had more trouble into instrumenting that kind of things. And furthermore, it gives you great service discovery, load balancing. You can have secret and configuration management. These are just a few of the great stuff about Kubernetes. However, when you start building a microservice, you start from application code, right? Then you add to it a Docker file, which is pretty much the container blueprint, how your application will be operational at some point. And secondly, to actually deploy and make your application operational, you start to create Kubernetes objects in YAML format. And you can create one or more files containing YAML. And then some question is coming up, okay, for one deployment, maybe I need 2 files. For 2 deployments in like different namespaces, different environments, maybe I need 4. Then if I'm multiplying these types of deployments and I want to like replicate them across multiple environments, or I have an application that's geographically distributed, how many of the YAML Kubernetes objects can I write? Like you can get like to infinite if like you are writing a very complex platform that has to be available across all over the globe. And thinking of that part with the infinite, and because most of us probably here are developers, in time, we kind of didn't like writing YAML because we kind of fear of writing YAML, long YAML files, because it's becoming like pretty difficult to understand at some point what you want to achieve with your application, right? And because of this, adversity, let's say, to the YAML format, we might need some automation heroes that can help us with dealing with YAML. So not writing as much YAML as it would be like needed, let's say, if we don't have anything else but Kubernetes vanilla. So the first helper in automation is Helm, the Kubernetes package manager. And the reason why Helm is helping you is because it comes, first of all, came with the concept of templates. So instead of like writing all the time a lot of YAML files where you just change the values for some of those keys, it's better to have a set of templates that can be applicable maybe to many of environments. So Helm has helped us to manage and update multiple Kubernetes configuration. That's one of the benefits by its structure and its templates. Secondly, you can deploy many configs as a single application. So when you are going to deploy an application with many configurations using Helm, you're going to use one single command that's going to look at all the templates. You're going to create those based on those templates and values. There are going to be some Kubernetes resources created. And of course, you will see that application deployed as a single release. So you will have a unified view of what you deployed. It's no more like scattered objects that you need to connect between each other, like which one needs which other. And secondly, well, the last one, you can parameterize for multiple environment support. So the fact that you have templates can give you the advantage of modifying just the values and parameterize to have that multiple environment support. And before going into some Helm differentiators and looking into more about what's great about Helm, let's do a little bit of live coding. So for today, I'm going to deploy on OpenShift, but the code that I'm going to share with you is actually code that can be installed also on Minikube or in other distributions of Kubernetes as well. So it's not dependent on the platform. I'm just using this as a playground. OK. Without further ado, what I'm going to deploy today is actually 3 microservices. I want to deploy an entire system using Helm and operators and see which one works better, or in which cases I could use Helm, in which cases I could use operators, and why. So the first thing that I want to deploy, well, this is called the ticketing system. That's based on two actions, I would say. So the ticketing system allows you to buy tickets for events or for entering a specific landmark. The events are stored in a microservice, which is Quarkus-based. And the landmarks are in, of course, another microservice, which is also Quarkus-based, so deployed on this one. The data, well, microservices, each microservice has its own persistent storage, right? So we don't have just one database. So each of the microservices will have its own persistent storage. And we're going to look into how we can interact with those. So the first thing that you could do when using Helm, for example, if you're the first time deploying or you're in dev mode, you can bootstrap the database using Helm charts. And in the README of these microservices, I can install my database just with one command, and of course specify even the version of the charts that I want to use. In this case, it's 10.14.3, for example, and query afterwards about the status of my Helm chart. So let's do that. Sorry. And install my event database. Hopefully the internet is quite fast. OK. I don't know why. What am I doing wrong? OK. After this, I can say Helm status event. So after seeing this, what I can see is that my database was deployed. So it says, please be patient while a chart is being deployed, because there's a stateful set that's being spinned behind the scenes. How I was able to install this database? Well, I referenced already published chart in another repo, in Bitnami repo, so it's somewhere available in the internet. And I just referenced this repo to have it installed in my own namespace. And you can see it here. Event Postgres is being instantiated and running. So just by that, you can provision a database. Sounds easy, right? But how about for our own microservices, right? Because we are building our own stuff. They're not available over the internet. We want to build our own charts. In this case, let me go here and go upper. So let's go and create a chart for event. Let me go to chart. I hope I have nothing in it. No, I have nothing in the chart. So in this one, I can easily create a bootstrap a Helm chart by just using Helm create and say event, which is going to create the Helm chart event. But if I'm having some experience with Helm, I can also use starters, which are code that I did for Helm before, and I know that it replicates across my microservices. So I can use these starters because they have maybe some custom validation that I could reuse for other charts. So I'm just going to say -- starter event and check the tree event. What you see here is not something that you would regularly get with the Helm charts, because it also has values.schema.json, which is for validating the values, because you want to make sure that maybe your colleagues are, putting the right ports that are allowed to be configured for your microservices. Or maybe there's a service account to do this deployment securely. All these stuff can be improved. And even more, you have a smoke test for testing the connection for the database, testing the connection of the microservice, that everything is going okay. So this is pretty helpful. Now looking at inside the chart and what was done here, it comes with some default values. So it comes with a repository being referenced and some values that I can use to instantiate my chart. So when I want to use these charts further, I can just modify these charts across my namespaces, and that's it. I don't need to struggle for more. Next, let's install this chart. And the easiest way to do it is just say helm install, give a name to our installation. In this case, I could say simple, and say it install from event. What this will do, it will look to the templates, create all the resources from here, and just replace in the templates the values that I've given here. And you can see now that I have my chart. It's at revision 1, is deployed, and I have a unified view of this chart. Furthermore, if we're looking here, the simple event is deployed, is up and running, and it's pretty good. That's just being simply instantiated. That's a nice feature of Helm. Furthermore, if I want to, let's say, deploy altogether the database and the application, I can do that as well with Helm, because there's another way of working with Helm. And let me go to Landmark, CD Landmark. I can work with the approach where I'm deploying everything, the leader chart approach, where I'm deploying both the database and the microservice all together, because they're dependent. I mean, without the database, my microservice wouldn't work. It kind of depends on that. So going to the Landmark, let's create the chart as well for the leader. Helm create leader, -- starter leader. But in this case of the starter, if I'm going to look in the leader, I can see it has a little different setup, this boilerplate. The reason being, I don't need the templates folder anymore when I'm using the leader chart approach, because I'm installing multiple charts altogether. So what I need this place called values.yaml, which is going to be my global location, where I'm going to define the global values for both the microservice, to be used by both the microservice and the database. And I'm just going to tweak my application when needed, and just customize when needed inside the other charts. What I mean by other charts? Well, there's a folder called charts here that doesn't have the microservice, right? So if I'm going to charts, clear, CD leader, charts, I need to create my microservice for Landmark. So similar to the other one, to the event, I can say helm create Landmark, Landmark -- starter Landmark. And this one is creating a starter for my Landmark, and just giving the same things as it has done before with the event. So tree Landmark, and voila, all good. This one even has an horizontal plot autoscaler set up to work with it. So all these customizations done, and furthermore, they can be installed all in one. Let's go here, helm install leader from leader, and just install everything for me. Come on, internet. Yeah, it was deployed. Now you can see that it's appearing here in the middle. It takes a little while to stabilize, because the database is going to be the first one that's going to attempt to be created, and this one is kind of waiting for the database to be available in order to have the microservice up and running. What's going on? And everybody woke up, right? If you were sleeping or tired, now you're waking up. And yeah, I don't need no more coffee. I should have had this talk in the morning, and it would have been way better. Okay, hopefully no more problems, and I hope I'm not to be blamed. Now that we all woke up and we are all very relaxed, let's look at some Helm differentiators. So there are some advantages with Helm. You could see that I could easily prototype, right? So I could prototype the application installation very easily. I can separate the non-final values, which were my values.yaml, from the actual objects. The templates are actually going to be used for my actual objects. So the values are not anymore hard-coded within my YAML. Secondly, I can deploy those many configurations, and you saw those many resources of Kubernetes, just instantiated what once, just with a single command, so that you don't need to do many more commands. And secondly, lastly, if you need to check, you can check nested values at every level. So for example, if you can have conditions for if-else, if certain values are provided, or in the values.yaml, and to make that portion of your YAML definition available only when those values are defined. But there are more distinctive Helm aspects. So for example, in deployments, what you can do, you can automatically roll deployments via annotations. So using annotations, you can have that. It doesn't come out of the box with Kubernetes resources. Another great thing about Helm is that it is supporting a lot of reusability. So it's encouraged by using the _helpers.tpl, so you can write even more of your functions for templating. You can use the include directive to include some of the templates, and of course you can use the TPL function to explicitly say that this is going to be a template. Furthermore, besides the automatic roll of deployments via annotation, when you are not needing, say, a Helm installation anymore, and you say Helm on install, you can actually tell Helm to keep some resources, even it will uninstall the charts, by using the annotation of keeping a specific resource for you. So if you really want to keep a secret or I don't know, a service account, but you don't want to keep any more a specific chart installation, you can do that, and you can instruct Helm to do that. These are very nice and great distinctive Helm features. Now, if you're looking at the demo, we have now 2 microservices deployed, all of them using Helm charts, right? So what happens at the maturity of a system? I mean, this works nice because, I just deployed 2 microservices. I can maintain them. It looks easy to maintain on the long term, or actually on the short term, because I'm just doing this in a demo. But if I'm going to evolve this even further and think how am I going to maintain a database? I mean, what if there's a database upgrade coming over and I need to upgrade my database? How am I going to deal with Helm in that? I'm just going to use Helm upgrade and expect that everything will be nice and working. How am I going to back up my database? Because sometimes you have to do database backups, right? And Helm cannot do this in case of the objects that are stateful, and the database is using a stateful object. So for this one, when it comes to dealing with growing complexity, especially for stateful resources or stateful applications, when you're looking into the future, and you're thinking about building something scalable, you're thinking of using operators. You need a way to package the human operational knowledge into something else, into operators, and instruct Kubernetes to control those stateful resources differently than from your stateless ones, and do some work for you. So there are some benefits of using operators, because they package the human operational knowledge, so you don't have to do all the time the manual kubectl or Helm installations or doing scripts and all this. They work automatically with clients like kubectl or dashboards, so you don't need a specific CLI like Helm to use an operator. The resources that are created via operators are secured, and they use HTTPS. And of course, operators can be used to create backups or for configuring your cluster. So for a long time, operators were there to help in creating backups of clusters or of different stateful applications in the Kubernetes world. Furthermore, you've seen the main application part is for dealing with databases, they're great. So what's next for the demo? The idea is that it would be great to replace at least one of our databases with an operator. And for Postgres, there are many operators available on operatorhub.io. Just choose one, pick one. You can follow the deployment instructions of that operator. So if you're going to operatorhub.io, you pretty much get also some instructions on how you can install the operator. You can isolate, like keep the Helm charts for maintaining the application, if your application, because that's something considered to be stateless, since you're persisting the state of your data, of your events in the database. You don't care that much about the application. You can still use Helm for maintaining that one. And last, you can maintain the PostgreSQL database via the operator. So when updates, when backups, restores need to happen, those can be done via the operator. So how about creating an operator? Well, you can also create operators by using Kudo, Kube Builder, Meta Controller, Operator Framework, or even the Java Operator SDK. So let's make a little break and replace our database for event with an operator. So in the case of an operator, and let me bring my operator up here. Where are you? Should be this one. Make it bigger. So my installation of my Postgres operator is here. Yeah. Also stateful set. I just need to use this one, just identify the secret that is belonging to this one. Now, I'm going to go the command line way and say kubectl get secrets, and that's probably going to get a lot of secrets from me, too many. But I'm looking for something that's prefixed by operator that contains the details for my database. It's operator event Postgres. So going back to my event, to my chart and values, I can simply go here and replace the event, just making sure that the service that's associated with this one, I think I need another service, which is event Postgres. And I can now replace my installation and upgrade my chart. So going back to clear event and say Helm upgrade, because I want to keep the revision history. I have installed something before, and in case something goes wrong with this one, I can go back to revision 1, right? So I'm going to say, hey, upgrade simple by using the information that is in chart event with my new values, the ones that I changed, and just make the changes necessary there. And just replace this by using the operator. So from the microservice point of view, nothing changed. Well, just some values, there's a different secret name and different service that it needs to connect. From the maintenance point of view of the database, you're just using you're using an operator, so you don't have to preoccupy all the time how you're going to back up using Helm. We got now to the revision 2. Let me just make sure that, yeah, this is still blue. This means it's deployed. Release this 2, and let's delete, of course, uninstall event, which was the database that we installed initially, since we don't need it anymore now that our microservice is using the operator. So we don't need the other one anymore. Okay, since we don't need the other one, let's go back to the presentation and thinking about creating an operator. Well, why we will need to create an operator? Well, we really do this just for pure looking at how we can build our own stuff to abstract that human operational knowledge and not do the human stuff anymore. So for the ticket store front-end service, I'm going to use an operator to install it instead of the Helm charts directly. It's just for pure showing that. So this is the final view that we want to achieve. Now from Helm charts to operators, there's an easy way. So you can start with Helm charts to automate, and you can build from that Helm charts your own operator. And that's what I did for the ticket store front end. I pretty much use Git as my repository to store my charts. And that's what I used here. Then I packaged my charts using Helm package command. Then I just set Helm repo index to create an index file for referencing the version of my charts, because you see this is 0.10, but I can have multiple versions for my charts, right? So I want to say to my operator, hey, use this different version of the the Helm charts to upgrade the this microservice. Then the standard git add, commit, and push. You pretty know those. Next, to create an operator from Helm charts is pretty easy. You just add the repo, your GitHub, and then with just one command, you can create your own operator, which is just the operator SDK init, by specifying that you're going to use Helm as the plugin, and of course saying which chart and which version. In this case, it's Helm chart 0.10. If you're going to look into my repo, you're going to see that there are 3 versions of the chart, so you can just play with that and see how you can initialize with different versions and have a grasp on that one as well. Now, when you're generating your operator, it generates, of course, the code for the operator, but it also generates a sample config, like how to instantiate so that you know how to guide yourself when you're installing your operator, when you're working with it. And this is the charts v1 alpha 1 ticket store.yaml. So it gives you a way on how to also run that operator. And let's do that. Going to ticket store and operator. Okay, make install run and start this one. Hopefully there's nothing wrong with it. Okay, started. And let's install the ticket store from the sample. Ticket store. Okay. CD ticket store. There. No, I can say kubectl apply -f operator config samples charts v1, the sample one that I showed you, that I talked to you about. Let me go here, landmark ticket store operator config and the samples. So here are all the values, everything that's being referenced and all the other parts. Just entering it and installing it into my cluster for the front-end part. Now I'll just look at this part and see where it comes. You can see that's also like appears with the Helm sign because it's an operator created from Helm. It's still being seen as that. But if we're looking over it, some data is being retrieved. So this is our tickets, our places where we can filter, like buy tickets and all the other great stuff with our nice front end. So just easier like that. Some takeaways, like from differences around this. Well, Helm is great when you're building microservice, when you're dealing with stateless applications. It's a great way to make automatic changes to those. They have a custom packaging format. And yes, it's great for development purposes, even for stateful applications like databases. But again, development purposes. Then it's great that it has annotations that are enhancing what's already available in the Kubernetes API for the resources available there. But on the other hand, if you're looking to maintain stateful applications, operators are the better way to deal with it. Or if you're doing some operational stuff for your, even for your stateless apps, that you feel that are difficult to maintain just with Helm. If you have like complex configurations or setups that are done at startup, maybe creating your own operator would help you more. You can deploy, of course, a stateful application and maintain it in a completely automatic way. You can deploy an application configured in a particular way across a cluster to achieve high availability, which is a great thing, and is great for using it for backups and for cluster configuration. The code, if you want to try it, is available at this part. So if you want to scan it, you can get it from there. And by the way, you can install each microservice, and everything is explained in the README of every file. And there's a nice navigation between them so that you can don't get lost between the code of 3 microservices. It's quite a lot. So that was it from my side. I'm just going to share with you some books and some links to some books also so that you have access to that. Some additional resources. Well, the Kubernetes Operators, it's a great book. You find it at the Red Hat booth. And Kubernetes Patterns, we don't have that today, but you can find it at the link here, dn.dev/katespatterns1. So I would recommend to read that one because it has a nice parallel between let's say, object-oriented programming and how the Kubernetes resources were thought or created. And gives you an idea why deployments and other Kubernetes resources were thought in such a way and not differently. It's pretty useful if you're like trying to understand more about the Kubernetes universe. It also talks about Helm charts. I think it talks a little bit about operators as well, but also about other innovations that happened regarding Kubernetes throughout time. That was it. Oh, sorry. I'm just gonna bring it back for a moment. I don't know what happened. That was it from my side. Now, if you have questions, I am welcoming those questions. I have a hat here that I can give to the person who asks most of the questions related to the presentation, if possible. So thank you. Sorry for the technical issues. Thank you for bearing with me, and questions, of course.